All right, welcome to the L2 Interop Working Group. We have a few things on the agenda today, starting off with updates and discussion on the ENS-based chain registry, moving over from the GitHub list, which is something that has, yes, been in the works discussion for a long time now. And I think we are finally making good headway here. So anyways, we'll talk more about this, and Unruggable, Wonderland, many others have been contributing to the discussion here. Agenda item number 2 is some work happening around multi-proving on the L2 side and accelerating the eventual shift to getting rid of the 7-day windows, pragmatic fast finality. Vitalik wrote a post about this a while back. It's linked in the agenda. And then last up is presentation and discussion on permit 3, some recent work from Echo. Cool. Starting off with Martin, whenever you're ready.
Great. Hi, everyone. My name is Martin. I'm from Unruggable. We're an independent R&D firm within ENS, and we've been working on the on-chain registry as part of the broader Interop proposals. So let me take it back. So ERC 7785 proposes the derivation of a 32-byte chain ID, and it also proposes that a human-friendly name for that chain, that is something like base.2.eth, resolves to this specific chain identifier. So we've been working to validate this, and we've built a proof of concept that works with ENS, that is ENS compliant, and has, it's brought out a few things. I've sent you the link right now. You can check out that demo. I'd like to maybe just go through the process of registering one chain while I share my screen, just to take you through it all. And then from there, we can discuss what it is that we've concluded from this validation that we've done. So let me just share my screen. Okay, so to start off, the ERC proposes using several attributes that will be hashed to get the chain identifier, and that is what we have here on these fields. We can have the chain name like maybe let's work with optimism. We can have the settlement chain ID, which is Ethereum. The chain ID is going to be 1. The version is something that the chains themselves decide. Roll-up contract, this is where the L2 state anchor, where it lives on the L1. And then the namespace, now these are attributes that are coming from Kype, and EVM chains are basically categorized as EIP 155. And then the chain reference in this case will always be the chain ID. So for this case, optimism, it's going to be 10. Based on this EIP 155 namespaces, it will automatically derive a coin type which is used by ENS to resolve to different addresses. So I'm going to just simulate this call. It's going to fail. Reason being, we already have an optimism that exists. So what we can do is we can just do an optimism 2 and then change the chain ID. We can simulate it, and now it gives us the 32 byte chain identifier. So I'm just going to go ahead and try to change this to register this, and then we can move on. I hope you can't see my wallets. There we go. Okay, so let's try this. Okay, fine. So that's going to register our Optimism 2 chain, and it's going to derive the chain identifier that ERC7785 specifies. So once we have this, we have two contracts in this architecture. The first one is the registry that's going to store all the information that we just put in. And then we have a resolver. If you go to assign now here, the resolver's work is very simple. We use Optimism 2, which was our chain name, and we assign it to the chain ID. We can check if it exists, it doesn't. And that's really the process. You first register it in the registry, and then after that, you assign it in the resolver, and then that's it. You should be able to resolve this name to its chain identifier and its chain attribute. So this is how we will be replacing the centralized list. Let's just wait for this to go through. There we go. And if we go to resolve and we want to check what we just recorded here and we resolve the chain, we're going to get back all the information that we had put in while registering this chain. So you can see the name, chain ID, rollup. The coin type was derived automatically. So that's just an overview of how we're going, we will register a chain and how we will be resolving it to its 7785 chain identifier. Um, One thing to point out is that as it stands, ERC 7785 does not use the attributes that you see here. These attributes have been modified to include mostly these type 2 attributes, mostly because of its connection to another standard. So anyone who's really interested, everything is on this land page, the original proposal, the spec, the source code for the registry, the type 2 aspects, and all the other resources. Yeah, what we would like most feedback on is the actual update for the spec, the ERC 7785 spec, and just general feedback on the registry architecture. Yeah, just those two, the spec and the registry and the architecture that we've put in there. Yeah, thank you. I'll take any questions.
Thanks, Martin. Any questions? We can also
Yeah.
go ahead, sir.
Actually, yeah, actually, I have a few questions. So the first one is the settlement chain ID. Isn't it better to use the resolved ENS name or the hash instead of the chain ID? Because the issue is right now that we have chain IDs that may collide. I don't know. I know that that is extremely, improbable, let's say, but still, isn't it better to move from chain IDs altogether in the future, and so not use chain IDs as a requirement, as an attribute to do the linking, I mean?
I'm not sure I understand what you mean in terms of the chain IDs. Do you mean it like as an attribute in the
Yeah,
computation or general?
yeah.
Uh-huh.
Like when you input the settlement chain ID and you say one because that
Yes,
is
yes.
Ethereum, is mainnet, why use
Mhm.
that instead of the hash or the ENS name of mainnet?
I don't see why not. I think these are things that ultimately we're
Hmm,
looking for feedback on. I'm not an author
okay.
of the ERC. But those are the questions we're trying to raise here because on top of we're trying to validate why are these attributes used and why were they selected. So, would really like to hear your opinion on that as well.
Yeah. And also, I believe I already asked this, but I don't remember when. Is this going to work for any L1 or L2 or just for Ethereum rollups?
So a very sweet side effect of introducing type 2 attributes is that this will support non-EVM chains because that exists for pretty much all chains. So if we were to adopt this standard and include those type 2 attributes, that is the namespace and the chain ID, we will be able to support, as a side effect, both EVM and non-EVM chains. Yeah.
Yeah, because that is actually, I'm not even talking about non-EVM, but just like, for example, roll up on BNB. That is still all it's EVM, but everything is non-Ethereum. So yeah, there's a lot. There's a lot of use case. Like it's not like like more than 10% of the chains, but still, I believe that we shouldn't like, since the GitHub repo is actually the place where everything gets in, that everything EVM gets in, we shouldn't be leaving leaving anything behind. Otherwise, the GitHub repo will still be used for some specific edge cases. There shouldn't be any reason to use the GitHub repo. So yeah, I'm just gonna provide some feedback in your repo as well. So thank you for now. And also the last question would be, can you provide like an example of how the transaction is being like displayed? Maybe you have because I saw that there is a transaction, so that is not an attestation. So you need ETH to.
Yeah, sorry to cut you off, Jack. I just want to be mindful of time. Maybe we could move this last part, maybe async to the chat. Is that okay?
Yeah.
Okay. Yeah, sorry to cut you guys off, but maybe just to keep moving things along. I do want to give it over to Skelly, I think, from Wonderland team. Maybe has a few things to add.
Sure. Just to continue with with the questions here and the concerns. We agree. The main idea for the chain list to be on chain is to be able to fully deprecate any, say, third-party dependency, that being GitHub or whatever, basically, and allow, composability, etc., to be basically to live on chain. This is basically why we built both 7828 and 7930, is to be able to accommodate for all and any chains. There are some limitations that we've been raising regarding ENS only allowing you to register 32 bytes. We are circumventing that on the resolver implementation that we already did. That's being internally audited by the Wonderland security team right now. Their repo is public though. I will share the link in a bit so you can check that out. Obviously, it's a non-standard resolver for ENS just because it needs to go above the 32-byte limit, right? That being said, on top of that resolver, you can just extend that, let's say wrap that to basically, create a subset of domains that use, whatever ERCs that you want to use, and that should work. You can also extend that to be able to add different properties to whatever you're registering, those being the portal address, the fault proof, this and that, or whatever additional parameter. Those ideally should be under an ERC, so people know how to basically quote and what to expect back as a value. But yeah, so that's it. We'll be showing you guys some links, and like whatever effort the guys from Unruggable are doing, it would be just like supported on the resolver that we built. So yeah, that should be fine.
Any comments or questions? Anything, maybe throwing it back to Unruggable guys? We can also, maybe this is, I don't know how relevant or interesting this is to the larger group. I think we've been meaning to schedule a smaller call for a while now with Unruggable, Wonderland, anyone else who wants to join, of course. So maybe we move some of this conversation over there.
Josh, if I'm okay to quickly jump in.
Sure, of course.
Just for context, I'm Thomas from Unruggable. Yeah, the work Martin's been doing on this We're obviously engaging with Josh and the team at Wonderland, but this demo is kind of a proof of concept of a registry contract and a fully ENSIP spec compliant resolver for resolving these chain IDs on a subdomain of whatever ENS name is chosen to go with. So L2.eth was one that was discussed, CID.eth was another one. In terms of Jack's questions, I think kind of the reason that a lot of these parameters have been included in the derivation of the 7785 chain ID is sort of so that you can interchangeably work with any of these values, assuming that you have that 7785 chain ID. So our registry allows you to convert between all of them. So if for whatever reason you need a CAPE2 identifier, for example, you can get that from a 7785 chain identifier. Same with the 7930 and the coin type as defined within ENS specifications. Yeah, I think that in terms of 7785, obviously, lots of people have been contributing to that, to the development of that spec, but basically that's kind of, I guess, the outstanding thing. Exactly what parameters go into the generation of that hash are up for debate, but we kind of need to agree on it. Ultimately, like the CAPE2 hash can be used for non-EVM chains, for example, but the standard chain ID one for Ethereum mainnet standalone is not particularly clear for non-EVM chains. So yeah, as Martin suggested, it would be ideal if people could kind of have a look at the registry and resolver contract that we built, as well as these specifications 7785 and 7930 as well, and comment now so that we kind of do it right first time.
Yeah. Yeah, no, and sorry to chime in, but it's just yeah, the thing about the chain ID was actually if we find a way to standardize chain identification like the EVM chain ID across chains that are non-EVMs as well, like I don't know, there's a parachain ID, or a Cosmos chain also have some kind of string that is attached to a chain identification. So if we can just hash that into a unified hash of a chain ID, and not the number of the chain ID like it's EVM. I know if it sounds like convoluted, but for example, this makes sense for a possible L2 building on Cosmos, whatever that may mean. But we know there some weird stuff has been happening lately of L2 becoming L1, so L1 becoming L2. So, so what I mean is simply like not using the EVM biased chain ID, but instead using a generalized hashed maybe chain ID, like the key, like CAPE2, for actually using settlement, like referencing chains between each other. That's just it.
Yeah, yeah, I agree. I think like even things like the rollup address makes the kind of naive assumption that rollups will all continue to work in the same way in the future, and that non-EVM chains work in similar ways. There's kind of outstanding questions. For example, what exactly goes into that role address field for a chain that doesn't post state routes to L1, for example. I mean, yeah, these chain identifiers for Interop could, in practice, be just a hashed version of the CAPE2 identifier, for example. Then, yeah, I mean, yeah, Martin and I have discussed this a lot. There's elements of 7785 where you kind of think to yourself, actually, do we need this? Does this solve the problem? Does it create more problems? And that's why, yeah, we need to kind of continue to have conversations about it, and people need to be kind of proactively engaging in the conversation, rather than sort of when it's getting to that stage of being very close to completion, people sort of coming out of the woodwork sort of late in the day. We want to kind of have that conversation up front.
Yes, I'd be happy to help with our experience and indexing chains across different ecosystems. Yeah.
Okay. Well, maybe on that note, we can move on to the next agenda item, if that's okay. Alrighty. We have DMart here from Flashbot's team, who has been waiting patiently for some discussion on multi-proving. DMars, whenever you're ready.
Cool, yes. Hello, everyone. Let me share my screen. Cool, yeah. So I think there's like a bunch of disclaimers to add here. We work with a bunch of roll-ups, L2 teams at Flashbots, and there's certainly conflict of interest. I think I'll get out of the way before when we like officially kick off this effort. But yeah, I wanted to basically talk about how we're going to start a working group to accelerate L2 multi-proving. And in particular, this is something that Ethereum in general has been very excited about. Something we're hearing that institutions are very excited about as well to ensure the highest quality of security on their assets on Ethereum. And so I put together this document, which I believe is on the agenda, and I'll just share in the chat as well. And it outlines a few of the sort of opinions that we want to take with this group in order to move it forward and maximize success. So yeah, the North Star here is for us is like to make multi-proving the default security model for Ethereum L2s with non-trivial value. And that doesn't mean everyone needs to do it, but we do want to kind of create this like very wrapped up package that people should be able to use. And so there's a lot of ways we can do this, but I want to share these like 3 goals that we want to start with is like 1, so we want to take the Pareto principle. I think there are an insane amount of roll-up architectures and teams, and I think that's super exciting, and I don't want to belittle any of the work there, but our goal is to focus on like the top 80% of TVL first in this like work stream. And that doesn't mean we can't eventually expand to more, or it doesn't mean that like other chains and stacks as well can't follow along and like contribute to this effort. But like when we're making decisions, like we want to ensure that like decisions are not blocked if they're like outside of this 80%, at least for the first phases. We want to take a research engineering approach. So the goal of the working group is not to have the finalized architecture in the sort of like first sprint or phase, but we want to progress via POCs to uncover unknown unknowns and not design for the end state by day 1. And then another concrete thing, is going to be very hard to do, but like we want to try and keep logos out of this as possible. And that's why I will do a bunch of conflict of interest sharing and all these things at first. But yeah, we really want to make it about shared marketing. Whoops, nope, that's the wrong word. We want to make it about shared architecture, not marketing. And so yeah, that being said, I think because of the 80%, we'd love to start kicking off an OP-Stack multi-prover POC and an Arbitrum Orbit multi-prover POC. And as well, another one of the work streams we want to enable is a design goals document for a multi-prover market interface. So there's a lot of interesting questions there, similar to like PBS on Ethereum L1 or L2s, where like how many provers is the ideal structure for liveness? What are the ideal liveness properties we want? Should like the cost burden be on the user, or should it be socialized? These types of questions we want to like dig into and have like an opinionated design document that we can propose to the community. And then longer term, we want to expand to greater than 90% after that, converge on a generalized multi-prover architecture, and build a shared open source code base if possible. So the rest of the document, I won't go through it, but it's sort of, we explain why, the risks of a single prover, multi-proving as the solution, what it enables. There's a document from Vitalik, which is the architecture that we most likely will go towards, but it's this pragmatic fast finality. And I can share that document here as well if you haven't read it. That's not it. Here you go. And so I sort of mentioned the North Star about this and the TLDR above, some of the guiding principles, and then our immediate goals for POC phase. Cool, so that's it. I'd love to answer any questions. And what we want to do is start assigning basically a coordinator for each of the POCs in the POC phase. And then we'll try to set up like some type of call, and we'll report progress back to this call as well. And yeah, we'll try to do all of our updates in the L2 Interop GitHub repo and the Telegram chat. Yeah, that's it from me now.
There's a question from Nam in the chat. Sorry if did you already answer that, DMARS? Maybe I missed.
Oh, sorry, I missed it. Supporting this in the proof system for the built-in canonical roll bridges or for applications using the multi-prover. Yeah, the goal would be for the canonical roll-up bridges at first. And on top of that, like for the POCs, I think the goal would actually just be to like have like a parallel bridge. So I think that's, I'm not sure what the, or at least that's how I've seen a lot of the ZK proving teams had developed their initial versions, was they just had like a parallel bridge that was like ZK proven. So I think it would be great if for the POCs, we like get that to testnet and validate that in like a semi-production setting. Would be very
I guess
curious, though,
maybe
if that's the wrong focus.
Yeah, I'm sure that could be a debate in of itself, but I think it seems to me what you're saying is that the kind of like the production end goal, which I recognize is not part of research engineering, but like the eventual goal would be for, let's say, base optimism arbitrums, like the canonical roll-up bridges, to basically move to this multi-prover system, and specifically within their interface.
Yes, exactly. Yes.
Cool.
Any other questions, comments? Thank you for coming on the call and sharing this. Looking forward to future updates on the multi-proving work. All right, up next, permit 3 from the Echo team.
All right, let me just share my screen. All right, can you guys see my screen? Looking good? All right. Hey, everybody. My name is Shra. I'm product lead at Eco. Long-time listener, first-time presenter, so bear with me. Today, we're going to be talking about something that we've been working on internally called Permit 3. I'm going to share these links in the chat after I present. So just, I'm just going to share the screen for now. And I want to reserve most of the time in this call for the time that we have to address some of the technical feedback. And I want to give a shout out and a thank you for the people who did start the feedback loop in Telegram. Thank you so much for raising the concerns and some of the changes, proposed changes. We really want to address those directly, hopefully if you have time in the call. But for those who are not aware, who are not caught up to the Telegram, I'll just start with a quick TLDR of what Permit 3 is and why we built it. And then I'm going to kick it to Kuriel, who's one of the lead engineers that helped build Permit 3 to address some of those implementation decisions. So quick TLDR of why we built Permit 3 is that Eco is obsessed with creating single-click stable-sign experiences. And we are Ethereum first. And what we found is increasingly with the proliferation of L2s, our users that want to do stablecoin actions have their balances spread across multiple source chains. And the extent of the best technology that we have seen so far to allow like really smooth interactions is Permit 2, but Permit 2 in essence is domain constrained. And really the UX, the single click UX we want to achieve kind of breaks apart with a fragmented balance if it's spread across multiple input chains. And so Permit 3 was built directly to address that problem directly. And quite simply, Permit 3 is a protocol that allows people to do cross-chain token approvals and transfers with a single signature. How this works, if I were to Eli 5 it, and then Kuriel can go into more detail, is that if a Permit 3 is set up once on source chain for the user, if a user has their balances spread across multiple source chains, in the applications that we build, we can abstract their balances into a single global balance. And then with a single signature, do any desired action they want, regardless of the number of source chain that their balances may be on. And you can think of it very simply as an extension. extension of the same pattern as permit 2, but in a multi-chain setting. So what happens on the back end when a user creates a permit 3 signature is that you can think of it quite simply as like nested permits that solvers in the eco intent protocol can then unpack on the relevant source chains and then create intents on behalf of the user. And those intents can either do the desired action directly when message sender is not a concern on the target chain, or what permit 3 can allow you to do is create intents to transfer the funds to the user, to the user's wallet on the destination chain, and then use the final permit to actually do the desired action for the user so that you can preserve the message sender and the attribution, which is very important for payments. So that's basically, it's very simple, but very powerful. And it really allows us to create really nice experiences. So that's basically the TLDR for permit 3. I'll stop here, and Kuriel, if your mic is on, I'm gonna jump a little bit into GitHub, and maybe you can help walk them through some of the architecture in a little bit more detail, and then we can maybe save some time to address some of the feedback that we saw in Telegram or any other feedback that people may have in the time that we have.
Awesome.
All right. Great, go for it.
All right. So basically, like if you're familiar with permit 2 architecture, is what they're trying to do is to create like a batch signing process where in one batch you can have multiple allowances, and also like it can be allowances for multiple tokens. And then if you've been using Uniswap, knowingly or unknowingly, you've been already using permit 2 a lot. And the general idea that instead of giving ERC20 allowance to the contract that you're working with, for example, Uniswap router, you will just create basically an infinite allowance to that permit 2 contract, and then permit 2 contract is your intermediary for creating single signature allowances. So we're extending this idea for permit 3 is now instead of creating a batch of approvals for a single chain, we're basically creating several batches. One is for each EVM chain, and then we basically create a Merkle tree from those batches and requesting only one signal user signature for that tree. Okay, so there is many things that you can do with permit 3, and like things that are different from Uniswap is the allowance system. So with Uniswap, you can have like asynchronous nonces, but you still like set an allowance as a final number. With permit 3, the change that we did is to allow asynchronous nature for environments where you have like a lot of transactions and a lot of authorization can be happening and balance can be adjusted. So in essence, permit 3 allowances, they're incremental. So they're rather operations like increase allowance and decrease allowance instead of set an allowance. And then for each chain, you create a batch, and batch inside of it can be also not uniform, because in one batch you can mix allowance increases, allowance decreases, and direct token transfers, and you can include as many tokens as you want. Then like you multiply it by amount of chains, and now you can have 5 chains, and for each of the chains you can put a batch with different tokens, different addresses being created allowance, and then you create a Merkle tree of the whole thing and create one signature. And one optimization that we also included here is we were thoughtful about gas cost and making sure that on the most expensive chains, e.g. Ethereum, we are trying to get as small Merkle proof as possible. So we're going to save up on the call data on the gas used. And to do that, we basically leaning heavy into using unbalanced Merkle tree. And in this case, for Ethereum, the amount of leaves that you need to supply for the proof is just 1. And then for cheaper chains, they can be like down the path in that balance tree. And in this case, we're not caring about the length of the Merkle proof. Do you guys have any questions? Do you want me to like elaborate on any of that?
Yeah, just one
Curious
question.
more.
I dropped
Yep.
a question in the chat, and sorry, this is also coming from me having not spent enough time digging into the documentation yet, but I'd be curious to hear
Yeah.
more about just sort of this. Yeah.
So trust assumptions for the off-chain system, like there was already a concern brought up that like, oh, now we're building a Merkle tree and the actual like underlying data is obfuscated from the wallet signing user. So, like the first, or actually the answer comes from the way you phrase the question is trust assumptions. In many cases, users still trust the front end or any other application that is using. Like when you're creating a permit to signature, you're also not exposed to much of what's going on under the hood. And even if there is more exposure into the 712 signing with like MetaMask wallet, there is still a possibility to do some phishing attack if the front end or any other software that it used is malicious. And another aspect of it, we basically just released, like final public release of the Permit 3 happened yesterday. And in the future, we're thinking about working with wallet providers and making sure that they can be supporting 712 signatures with nested Merkle tree data structures. So as right now, like it is not ideal, but we are working on that, and we're seeing that in near future, as we get more traction and user adoption, the wallet is going to be able to understand, hashing of the substracts and organizing it into the Merkle tree and presenting it with a nice UI. Cool. And just to give you like a little bit of idea why Permit 3 is so powerful for us, like it basically combines together nicely with the intent system that we are building, where to create an intent, we're basically just doing user lock into a unique vaults. So for each vault, for each intent on the source chain, unique vault address is created. And then for user to create an intent, the only thing that is needed is to transfer that required token into the vault. And with Permit 3 and gasless system, all that it needs is to create allowance for that vault, and then vault is capable to pull from, using like transfer from and pull from that allowance. And with Permit 3, in the gasless experience and a stable coin experience, all user needs to do is sign a message that contains permits for a bunch of chains, and those allowances that are created going to be for different intent vaults. And in this case, just with one signature, we create as many actions as needed on as many chains as needed, and that enables us to bring ethos of eco to any user, which is with one signature, user can create any amount of actions with stable coins and achieve any amount of results.
Can I ask a question?
Yeah.
Like the worst case scenario, let's say like the spender does nothing or just like drains my tokens and walks away. Like what recourse do like I as the user have to get my money back?
As blockchain, it's a simple send with ERC20 or given allowance with ERC20. If an allowance is given to malicious actor and token is transferred, there is nothing can be done, because Permit 3 in essence doesn't create balances or wrap in tokens anyhow, so it's only like managing allowances. And let's say if allowance was created and then like some for the contract, let's say contract gets compromised, we support a system of locking down the allowance, and it's similar as Permit 2 does it. So you basically have an emergency path to disable allowances for a certain actor.
Got it. So there's no recourse, I guess, in that case. Would you say that is there a way that enforces like, I guess settlement outcomes? Because like, what if I say I want to do one thing, but something else happens instead? Is there a way to enforce that at all?
I think not with Permit 3 directly, as I mentioned, because in his ERC20 allowance, whoever give it to or like whoever sent token is done. But if we're talking about the whole ecosystem, we're pairing it with our intent and our intents describing clear action that can happen, and then that action is abstracted away by behind that unique vault address, and then you basically create allowances for specific intents rather than like huge wide allowances for the whole smart contract. And then intent can only result into desired action, and if it does not happen before the deadline, then all the funds are refunded. So I hope that answers your question.
Okay, got it.
Any other questions for the
All right. And just, I hope no more questions on that part, so now we sort of covered, all this powerful experience of having one signature and being able to move as many ERC20 tokens on as many chains as you wanted. And when we created Permit 3, we were like solely thinking about cross-chain experience, and we were Googling other Permit 3 like ideas and implementations, and there was nothing. And then like at the late stage of the audit, somehow 2 more Permit 3 projects came up that was done like some time ago, but never gained traction. And a lot of like their innovation were to expand beyond ERC20 tokens. And that means supporting NFTs and supporters ERC1155. And we decided to hop on the train as well and make sure that we are not competing with other like Permit 3 suggestions, but rather improving what came before. And what else we added is with our Permit 3 system, in one signature, using create allowances for ERC20 tokens, allowances for NFTs, and ERC1155 tokens as well. And allowance can be per unique NFT ID, or user can say, I give like a wildcard allowance for 5 NFTs that I own from the whole collection. So yeah, this is some additional bonus that we support right now. And in some future, we're also planning to bring ERC, basically NFTs and other like token standards to our intents, and create like a whole ecosystem where with one signature, user can basically authorize any amount of any types of assets and create any kind of complex cross-chain actions where user just gaslessly creating one signature and covering everything. And also, like, I wanted to mention that we are utilizing the benefit of ERC 7702, and if user completely trusts Eco and they don't have smart account, smart wallet, or they can upgrade, just do 7702 upgrade for Permit 3 approver. And what that thing does is it allows to create ERC20 approvals for user tokens to the Permit 3 contract without any user input in the future. So that means like with doing 7702 upgrade, user creating like infinite allowance for all their ERC20 tokens for Permit 3 contract. And in this case, like future tokens, all things like that can be just, like already available and be just behind one signature. And if user has a smart wallet, we also created a smart wallet module. So like any user can install that module to their smart wallet and also enable that behavior.
Awesome. Well, thank you, Echo team. It's great to learn more about it.
Awesome. Thank you, guys.
Thanks, everybody.
All right. I think that maybe brings an end to this week's call. Thank you all for joining. See you next time. Adios.
Thanks, guys.